All right, good evening, everybody. Nick Yen here, checking in. Student Learning Outcome 3A, Section 4.1. I picked problem number 3, and that is a word problem where we're working on related rates. Usually I do these videos from my shop, or from my office rather, so I call my shop. But yeah, I don't have a whiteboard behind me, so we're just gonna go off my notes. So typically what I do on these videos is I show you my notebook that I'm working from. Same notebook all semester long. We have problem number 3 here, and then we carried it over, all the calculations, and then the answer summary here. So we'll start off by reading the word problem. A spherical snowball is melting in such a way that its radius is decreasing at a rate of 0.1 centimeters per minute. At what rate is the volume of the snowball decreasing when the radius is 9 centimeters? So we're looking for volume. We're looking to find the change in volume with the rate when the radius is 9 centimeters. So the first dr dt, if you want to call it, I mean that's what we're going to call it. The change in radius with respect to time, and then the change in volume with respect to time. So the first change in radius with respect to time, which is dr dt, is going to be 0.1 centimeters per minute. And then we're looking to solve for dv dt. So my initial formula, given that we've been given the volume formula, which is 4/3 pi r cubed, we're going to have to work with that formula. So you can see here we have dv, maybe that's not clear enough, maybe right here. So d over dt times v, and d over dt times 4/3 pi r cubed. So that's what we're working with first. When we start to look at that equation, 4/3 pi r cubed, we need to do the implicit differentiation. 4/3 pi is a constant, so we would multiply the cube, if you want, I guess the exponent 3. We're going to multiply the exponent 3 by 4/3, which cancels out the 3's and it gives us a 4. And then we're subtracting 1 from the exponent, so that would leave us an r squared. And then we're adding a factor of dr dt. So effectively we have an equation that is dv over dt equal to 4 pi r squared times dr dt. And now we use substitution, right? So we have r, which was given in the original equation, or I'm sorry, in the original word problem, r equals 9 centimeters. Dr dt, so the change in radius with respect to time, is 0.1 centimeters per minute. And we just plug everything in, right? So we have dv dt equals 4 times pi times 9 squared times 0.1 centimeters per minute. That gives us 101.788 centimeters cubed per minute. So what is that telling us? So if we reread the problem, at what rate is the volume of the snowball decreasing when the radius is 9 centimeters? When the snowball is melting and the radius is decreasing at 0.1 centimeters per minute, and the radius is 9 centimeters, the volume of the snowball is decreasing at a rate of approximately 101.788 cubic centimeters per minute. So effectively we used implicit differentiation, and then we had our inputs, which again, r equals 9 centimeters, dr dt equals, dr over dt is equal to 0.1 centimeters per minute, and then we just start working through it. So here is number 3. You can see here. I hope that comes in clear. I figured that would be, the fastest one to explain without stumbling over my words. I don't like doing this way because I'd rather just walk through it, but obviously we can't do that today. Anyway, thank you.